Welcome back to the second class of our set. If you could recall in my first class, I told you that this is a journey that we have to walk through it together. So you have to follow me as we crack the wall of sets. I remain your tutor Latif Ismaila Akombi. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent contents. And don't forget to share, like, as we move on in this class. In today's class, we are going to be starting with empty sets, finite sets, and infinite sets. What are the meaning of this? 1. Empty sets. The word empty is what we all know, which means nothingness, something that has nothing in it. With me, an empty set is a set, though containing some elements, but those elements are not realistic. Those elements doesn't really belong to that particular set. We say this set is an empty set, or we call it a null set. N-U-L-L, none. What are the examples? If we say example of a set which is empty set, we say a secondary school student of age 3. This is someone of 3 years of age and secondary school student. Definitely is an empty set. Or we say that a rectangle with 5 sides. A rectangle, we all know that it will have only 4 sides. But we now said that a rectangle with 5 sides, this is an empty set, is a null set. An empty set is denoted with this symbol. This symbol or this symbol. So any of these two symbols can be used to represent empty set. Either we use this or we use this. Anytime you see each of these one, they are referring to as an empty set. Then, finite sets. A finite set is a set in which all the elements can be listed. The elements of a set. If we can just list everything in a single listing, we refer to that set as a finite set. Say for instance, a set of natural numbers between 2 and 10. Set of natural numbers between 2 and 10 means we will not count 2, we will not count 10. We start from 3. So it's easy for us to count everything. 3, 4, 5, 6, 7, 8, 9. Because we can count everything, this is now referred to as a finite set. But sometimes we can use some dots to represent the filling of gap of those elements. For instance, we have a set A. Let's say for instance, we have a set A. A equals to natural numbers between 2 and 50. Meaning, we are not counting 2, we are not counting 50. Natural numbers. And natural numbers start from 1. But here it has been restricted to between 2 and 50. Now, I'm going to start listening. 3, 4, 5, 6, 7. But instead of me to list everything, I cannot use 3 dots. To show that some elements are still here, then I will now write the last one. So the last one is going to be 49. So in this case, all these one, they are the elements of A. But because it's easy for me to list all the elements, we call it a finite set. While infinite sets are sets in which all the elements cannot be listed. It can continue. So it's an infinite set. So infinite set, we use 3 dots to represent it without having a last number. Let's say for instance, all natural counting number. All natural counting numbers start from 1 and continue like that. So if I want to write this, it will be, let me say set A. Set A is equals to natural counting numbers. So A will now equals to 1, 2, 3, 4, 5, 6, 7. I can't list everything. I have to use 3 dots. So don't forget it is 3 dots. So this example now is an example of infinite sets. Let us now look at this subheading, subsets and proper subsets. What is a subset? A subset is a set that is contained in another set. The word sub means part of. So a subset is a part of a larger set, while the larger set is what we refer to as a proper subset or a superset. What do you mean as an example? Looking at these two examples on the board, we have set A, mango, banana, orange, and pawpaw. While set B, orange, mango, banana. Actually, when we look at this B contains some elements that are also in A. Some elements in A, while A contains all the elements in B. Meaning A can consume B, while B cannot consume A. B can only take part of A. We can only match B to some parts of A. Orange match to this orange, mango to mango, banana to banana. So, which means that A can consume B. When A can consume B, we say that B is a subset of A, is part of A. So, which means B is a subset of A. Or in some textbook, you see it like this. So either a single one or putting a line under it, it means B is a subset of A. But because A contains all the elements of B, in this case, we are going to say that A is a proper subset of B. So A is a proper subset of B. So either you write it this way or you put a line under it to denote a proper subset of B. The next subheading, we're going to be looking at universal sets. Before the proper explanation of this, if you have not subscribed to my channel, please don't forget to do so before we move on the explanation of this and subsequent one. And don't forget to like and also share this lesson so that other learners can also benefit from it. Now, set A. As we have discussed under subset and universal sets, set A contains mango, orange, banana, pawpaw, while set B contains mango, orange, and banana. We can now see that set B is being contained in A, meaning set B is a subset of what? A. So this A can be called a universal set. So this universal set is denoted by the symbol. We have two symbols that we used to denote universal sets. This is the first symbol, or we use the symbol this way, either this or this. Any of them can be used, but this symbol is used for a unity or unity, an entity, while this one is used for a universe. How we're going to use it, we're going to see now. These two, we only have two things here. We have the universal set and we have this B. So if I want to represent this in a Venn diagram, so I'm going to have the universal set this way. Let me do it this way. So I use this symbol to represent universal sets. Now, B can also be found inside what? A. So B is a subset of what? A. So let me put this inside. Now, all the elements in B, which are mango, we have orange, and we have banana. Now, you can also see that there is one element that cannot be found in B. What is the element? Pawpaw. Pawpaw will be here. So, this is the universal set that consume set B. So, this one now is set B. This one is set A, which is the universal set. So, in this case, this is the universal set. The universal set is the whole set that contain all the subsets. All the smaller edge sets can be found in it. So it is called a universal set. Let's for instance, the country I am now, I'm in Nigeria. In Nigeria, we have so many states. So Nigeria is a universal set. While the states inside Nigeria, they are the subsets of the universal set. Example 4. Given the universal sets A, B, C, D, E, F, G, H, I, J, V, vowels, C, letters of the word cabbage, H, letters of the word heat. Question A. List the members of V and C. B. Draw a Venn diagram showing the universal sets V, C, and H. So let's start. The first question A, before you can solve the question A, you have to write some certain thing out. This V, they said only vowels. So you have to write the letters of those words in a vowels, which is what? A, E, I, O, U. So V, A, E, I, O, U. Secondly, C. Okay, we have C as well. Okay, we have C. Then H. Letters of the word heat. So we have H, I, D. Are we together? Also, let us write the letter. Let us write that C out. C. Letters of the word cabbage. C, A, B, G, E. Don't forget that we have 2B here. We only write 1. We have 2A. We only write 1. Cabbage. So how many letters? 1, 2, 3, 4, 5. Just 5 letters. Let us now go by our question now. So for question A, we want to list the elements, the members of V and C. We have done it already. This is V and this is one is C. So this is question A. Now our question B is to now draw a Venn diagram showing the universal sets, showing V, showing C, and showing what? H. Now how are we going to do that? Please, we have to be very, very calm to check it very well. We have B, we have C, we have H. And don't forget our universal sets, A, B, C to J. Now back to this. The first thing, let us denote our universal sets this way. Let me remove this solution. I will put my universal sets here. Out here. Then how many sets do we have? We have V, C, H. The first thing you will look at is this V, C, H. Let's look at V and C. Do they have anything in common? Do we have anything? Yeah, we have A is here, A is here. They have something in common. Definitely V and C will join in a particular point. So this is my V, this is my C. Are we there? Okay. Do V and H, do they join? Do you have anything in common there? I think we have a common. I is here, I is here. Okay. Do C and H, do they join? They did not even join. But there's no element here that is here. But V and H, they have some elements in common. With me, H will join with V. H will join with V. So this one is H. Let us now look at it now. Okay, in V and C, what are the elements that are common? V and C. We have A, you put it here. We have E, no I, no O, no. So which means we have A and what? E. Okay, when you now remove, okay, let us now check again. Out of V and H, they have something in common. V and H, what do we have in common? We have I in common. You put it here, I. Then you cannot write the elements now. If you look at this V, look at this circle. Look at my hand now, this circle of V. For my hand, A, E, I has been taken away from V. A, E, I. What do we have left? O and U. O, U. Look at the circle of C as well. In C, A and E has been taken away. A and E. What do we have left? C, B, G. C, B, G. Look at H as well. In H, what has been taken away? I has been taken away. We have what? H and what? D. So you can see the way we carve out this particular Venn diagram. We are able to solve this particular question. So it involves a calmness. It involves patience for you to bring out everything. If not, you can mess up things. I believe you understand it better. Example 5. If the universal set equals to days of the week and T equals to days beginning with capital letter T, draw a Venn diagram showing the elements of both of them. The first thing is to show our elements. Show our elements. Days of the week, we have Monday, Tuesday, Wednesday, Thursday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. These are the days of the week. Where T, they are the days beginning with T. Tuesday, Thursday, I think those are the two. Now, draw a Venn diagram showing the elements. If you look at, this is the type of Venn diagram they gave to us. Meaning, this is what you're going to draw, this box. And you put your universal set here. Our T, set T will be inside. Set T. Now, if you look at this set T, all the O elements in T are also in the universal set, which are T is here and TH is here. Okay? First of all, list the subset first. List it first. Tuesday and Thursday. Now, if we now remove Tuesday and Thursday, the remaining one are Monday, it will be outside here, Wednesday, Friday, Saturday, Sunday. So in this case, you are able to draw the Venn diagram showing the elements this and T. So in this case, these are how to go about this. And don't forget, this class still continue. Watch out for the third class of this as we will deep down the set. If you are just joining us for today, kindly check the description below to watch the first class, and so join us for the next class as well. Don't forget to subscribe to my channel and click the notification bell for my subsequent contents. Also, don't also forget to like, share, leave a comment as we move on, and leave your love emoji. Thank you very much. We meet in the next class.